welcome back to our OpenCV series. For the past week, we've actually done a lot. We've gotten some good knowledge of OpenCV, and we've handled some interesting projects. So today we'll be looking at another interesting project, actually a very practical one that is used in day-to-day lives. So we'll be looking at text detection from images using OpenCV. So, of course, this is one of the most important and practical use case of detection models, especially in this century where we have loads and loads of information that are in scanned documents, that are in printed papers, that are in handwritings. If we want to look at the time it takes to digitize documents, probably type with our fingers, it will be we can never we can never digitize all informations if we have to do it manually. So this model will take a picture and detect some text from there, and probably just like you've seen here, right? Get it out, and then here too you can also get it out. So all right, so what are the methods for doing text detection? Now, generally, text detection is done using optical character recognition, OCR, and there are so many of them. We have the Tesseract OCR, which is one of the most classical object detection optical character recognition model. I think it was built using I think Google was the one that built it. For example, the Tesseract which we will use in this our project comes from here. It's classical, one of the classical, and it's simple and lightweight. We have other ones like the easy OCR, which we also use in this project, which is very perfect for multilingual text. So when you have French, Arabic, Portuguese in your text, so it's actually the best model for that. We also have other ones like the OpenCV Craft, the TR OCR. So we have this here. We have the strengths, and that's when you should use it, and where it's really strong. So now, what's really different between easy OCR and Tesseract, because those are the two models that we'll be using for our project. SEO basically uses neural network deep learning by training, right? While Python uses rule-based pattern recognition. So as a result, easy OCR, while it performs better, right, is slower than the Python list on my machine. Okay, so for this we are not going to build these two tools from scratch. We'll use existing libraries to carry out our text character recognition, and also so that this video will not be very long. It will straight to the point. We have done a lot of we've already done a lot of OpenCV projects, so there are some things we'll not say again. We're not going to explain it any longer. You can watch them in the previous videos. So we'll simply go straight to the point, and then we're done. So all right, so let's quickly go to our IDE. So again, we're using the Visual Studio Code as our IDE because it's easy to use. And why do we need more complex IDE? All right, so let me just call this ocr.py, creating a file here. All right, first of all, we are going to import CV2, conventional for all OpenCV projects. Then we are going to import OCR, easy OCR as OCR. Right, please take note that you need to install this using the pip. So you can simply use pip install easy OCR if you don't have it on your device. It's available for all versions of Python. Then let's just import matplotlib.pyplots as plt. This is in case we need to plot rather than use the image we may want to plot. All right, so let's get our image. So for our project, there are three images that we will look at. There are two images that we'll be looking at. Let me just quickly show them to you. So we're looking at this image. You can see the beauty of this image is that all of them have different tones and different sizes. You can see, you can barely see this Don's Gains bar. You can barely see it, and you can barely see what's written under here. So we want to see how it performs different shades and different colors. Then we also have this conventional scan documents that we have here, and see how we can recognize this text. You can see some are italics, some are blocked, and some are in normal text. So we see how it performs against this kind of text too. So let's go back to our code. All right, so let's get our image. So let's just say image is equal to um um cv2 dot image. All right, so we have it here. Then of course our let's create our detector. The next thing we need to create our OCR. The first thing is to create an OCR detector. So what kind of detector do I want? So I have this as OCR.reader. Sorry, the reader. This is just the kind of detector we use. And remember, I said that the beauty of easy OCR is that you can use it with different languages. So the first thing we'll add here as the attribute, what language do I want to use, which in this case will be English. You can use French, you can use Arabic. Almost all languages, big common languages are there. Then we have the GPU. You have to tell it whether you're using a GPU or not. So if you're using a GPU, is great. I'm not using a GPU. So now that that's been done, the next thing is to involve our detector. It's as simple as that. So detector.read text, right? It's going to read the text, and then we pass our image to it. Simple as that. And it is going to go through your image and try to detect text. So let's print this out and see what you're going to get. So let me just run this, and then you see what you have. Okay, so thing is out here, so we can look at it. These are the texts that detected. You will see this first. The first bounding box here tells you the first things you have here gives you the bounding box right around the text it has detected. Then this is the text it detected. So like this is the location. You can see one. This is 1, 2, 3. Sorry, one, 2. This is the first one. The first one. This is the second one. 3, and of course this is 4. That's it tells it all the locations, the four corners of the box. All right, and this is the text it has located. This of course is the confidence level, which is very good in this case, 0.666. That's 60%. It can go as much as 100%. Yeah, so Now, if you go back to our, this is what it's trying to detect. This text one, you can see this is the Wilson kitchen, which it has detected, and at that location. The next smaller one with good food, good wine, good times. Let's see if we detected that. So you can see here, good food, good wine, good times. Okay, and this is where it is. This is the bounding box. Okay, beautiful. So that is, it has made the detection incredibly well. Though this is not a bit. This is a bit not what it's there, but it's fair enough. Okay, beautiful. So let's make it. Let's print it out. We want to print it out because we don't really need to see all these jargons. Does not look very good. So let's just um print this out. So all right. So we have that for, remember we have three things there. We have the bounding box, we have the text, and we have the um, confidence level, or the temperature to say. So I'll just say bounding box, text, and then temperature um, in txt text. Just call it text. All right. If the temperature, now remember that you can see a lot of jargons there, like the dots. Maybe there's a small dots there, which it's from ink or maybe printing error, right? You can see that. So we want to filter out. We want to filter some things out. So let's just put our temperature level at 0.4. Anything lower than that should filter out. Um, what do? I want to print. Sorry, this is a text, so let's just keep this as txt so that to not be confused. Print. We want to print the text. Then, of course, we want to get the bounding box, so we want to get a rectangle around that text on the image. So cv2 dot rectangle image. Sorry, image 0. So we need it. Once we have the top edge and the two edges, we are fine. We're good to go. So we have this and we have this. We just need this to create a rectangle. The the um the top and the top left and the bottom right is just what we need. So with that, we can create our rectangle. So the next thing will be probably the color. Remember that OpenCV uses BGR, blue, green, red, not RGB, red, green, blue. Please take note of that. So let's just make it red. So that means this will be 0, 0, 255. All right, 0, 0, 255, and then the thickness. Let's make the thickness 4. Let's make the thickness 4. Then all right. So that's that. So let's just plot this. But before I plot, I want to change it back to what we know. Remember that Matplotlib we use conventional RGB, so we have to change from BGR to RGB so that Matplotlib can understand it. So it's going to take an image and it's going to take cv2 dot sorry BGR to RGB, color BGR to RGB. So PLT dot show. I think that's that. So let me just run this again and let's see what you're going to have now. Oh, so it says CV2 All right, so here it says CV2 has no CV2 color. No, this should be CV2. This should be CVT converts color. So let's run this again, and I think it's going to work now. So this now seems to, yes. So this is it. It has detected the Wilson kitchen. Uh, for some reason it has not detected the good food, probably because of the temperature. It has not detected this. We have did not add this temperature. Probably temperature is 0.3 something. Probably. Then detected this. So if you lower our temperature, it's going to detect this. So you can see here, these are the texts. It can be copied. The Wilson kitchen, Taylor family, Patrick, Ella, John, Sharon, this and this. So it's just simple as that. That is how we can detect our text using the easy OCR. Beautiful. Please, if there's you have concerns or you are please free to use the chats. If you don't, please give this video a like. So now this is for easy OCR. Remember, I said that we use both the easy OCR and we also use Tesseract. So now we'll use the Tesseract to also carry out this task. But first of all, let me just close this because this has been done, and then let's create another I'll call it Tesseract .py, and then you can start. First thing you do, of course, I'm going to import CV2. Then next, I'm going to import Tesseract. Yeah. So please again, you can install this using pip install Tesseract. Then of course I'll need an output. So from Tesseract, right? Imports output. This is great. We have this here now at this point. So now um there's a thing about Tesseract. Just installing this on your just having this on your ID is not sufficient. You also need to install it on your local device on your path. So what you do is you go to this GitHub page, developer page, this GitHub page, GitHub UB man this, take note of this, and then you go down and you click here. From here you can download it. You can download this and then install it. Once you install it, you have it here in your local disk. You'll be able to see it in your program files. Just go to your program files. How do I get here? I'm my local disk, then program files, then I go to Tesseract OCR. Then what I'm looking for is the Tesseract itself. Yeah, this is it, the application itself. This is it. And now copy the path. It's very, very important. Okay, what am I going to do with it? But first of all, let's import our image. So for this, I'm going to use this with this other image test. So our image is equal to cv2 dot inread. I think test dot jpg. Okay, I think I will have to change this to this. Great. Then of course this Tesseract, unlike conventional OpenCV, uses RGB, not BGR. I've already explained that OpenCV takes image as BGR for no reasons of altogether. I don't know why they do that, but whatever is the reason, it must be there. I don't know, but whatever is the case, we have to convert it back to the one we understand. So we have this as cv2 dot cv2 dot cvt cvt color take image. We've done this before, just recently. cv2 cv2 dot color bgr2. Okay, I think that's fair. That's fair. Then by Tesseract dot this is very important. Tesseract cmd will be, this is the command you need. You need to tell it where exactly Tesseract is on your system. So that's, and I'll put this here, put the paths that I had copied here. So let me just like this. Right. So then of course we want to make our detection. So making detection is very easy. You just call it results is equal to by Tesseract dot image to text. Image to data RGB. Then how do I want the output? I want it to be in the form of vision. I'll just print it out for you to see. So sorry. Output type is yes. So now we'll now loop over. Let me just print this out how you see. Remember I said we need to print it out as a dictionary. So that was a problem. So we have to run it again. Okay. So these are the things you are seeing, which is very interesting. Very, very interesting. Very, very interesting. Very, very interesting. It has seen space. Gaussian blur uses a Gaussian function, a bell curve to determine the width of numeric pixels. Then these are the spaces. This, you can see this star. This produces a smooth, natural fallout, fall off from the center pixel, mimicking how light or lenses actually blur in real life. In contrast, other filters like average box blur gives equal weight to all pixels, which can create harsh natural edges. So let's see if this is okay. I think this is it. You can see, right? Exactly what it has found here. Looks good. Looks very good. Looks very good. Incredible detection. Okay, beautiful. So you can see all other stuff that it has found here. You can see the weight, it gives the weight, it gives the level, um, gives the block number, the page number, and so on and so forth. So these are the other attributes which we may not really need. So what do we do now? Let's just, we have a lot of crap here, so let's take the unimportant things off and then get the important ones. So we are going to loop over this individual text location localizations, and then what I want to do is I want to put the text on top of this, what it has detected on top of this. I can optionally print it out here the way I did with OCR. I will still do it, but I just want it to be beautiful, so I'll put it in front of the slide to look like something like this. Yeah, a Apple support. I just want some to show that I've actually seen that text. Beautiful. So let's do that. So for I in range 0, and then len um results, right? Remember we had a text here, so it's going to pick this as a dictionary. It has the level as the key, levels, page numbers, par numbers, word number, and all this. So this is text. This is what we're interested in, the text. So the text, then x is equal to results. Where is it? And then y is this result. Then we have this as top. Then of course we have the x and y. Then we need the width and the height to create a rectangle. So we have that w will be this as width, and you have our h equal to this, our height. All right. So that being said, um, we have our text is equal to results text. Right. Then we will need to check our confidence level, which we explained earlier. Unlike the other one that was in decimals 0.6 something, this is in percentage, so we'll have 20, 30, and so on and so forth. So confidence will be so it's a very robust result. You can go through them. You can see it's actually extremely long. All these are within the Tesseract result. So this as confidence, and then of course I. Beautiful. What do we now do with this information? um we have to filter the confidence. So if confidence, let's make it 20 so that it's you can see more, is greater than 20. All right. So I want us to display the confidence, and do I really need to see the confidence? Do I need to do that? Do I need to see the confidence? Let's just put it so we can see it. So print just print it out. Then let's just print the text. Alright, so let's just print it so that we have some spacing between them. So let's just print this and something empty here. Alright, so that's been done. So let's just print this. Yeah, let's print this before we let's run this before we get our image out. So let me just delete this. Some mistakes. Alright, these are the text that's in. Very good confidence, so you can see it's so long. Gaussian, the confidence of 73%. Blur uses text A, very good confidence. So this is it. So, but this is not just what I want to do. So let me just remove this. I just want you to see this. I want to put it on the text on the image. So how am I going to do that? Of course, CV2 dot rectangle to draw the box around it just the way we did before. So we have CV2 dot rectangle. We have this. We have our image. We have X and Y. And then of course the where is it? Was where would the lower right be? To be at X plus width, then Y plus height. So here will be X. Then we have Y plus height. Okay, because what do we need? Do we need a rectangle? The color green. So 0, 2, 5, 0. Then this should be the rectangle. And then the thickness, let's make it 2. I'll make it 2 thick. Then of course, the next thing we want to put our text there. But the thing is, OpenCV does not recognize as non-ASCII characters, so you have to remove characters that are not ASCII. So let me just show you. So characters that are not ASCII is always less than 1 to what order 1 to 8. Right. Before doing that, of course, we want to strip just to make it neat. Beautiful. um wondering why this is all right. So this is just lists all right. So let's put this text there. Image text. Where do we start? XY, right? Where it's the text began. Then of course, what style really matters, because when you are putting text, if it is too big, it will not look very nice. So we want to put it in such a way that someone can easily read it and it will not overwhelm the picture. So that's why I'm going to pick a very simple font. CV2 dot font. I want to pick the Heishi um font, Heishi simplex. I don't like this font Heishi simplex. It looks more like a quality thick handwriting. I don't like it. Then what else are we going to add there? We need to put our font size 0.5 so that I can easily see it. I don't want it to be too large. Then of course the color, um 0.0255. Right, so that's just a random color. You can pick any color you want. It's up to you. The thickness, just 2, but the thickness is different from the font size. So yes, that being said, so cv2 dot intro. All right, so let's just run this. This one is just all right. That's just housekeeping. So let's just run this first and see how it goes. Some images. This is saying what is it saying? All right, I just had to reset my Visual Studio Code. And things fixed. I was wondering why I could not see CV2. So let's just run that again. It's crazy. Alright, so we can see this. Gaussian blur uses a Gaussian function to determine weight of neighboring pixels. This produces a smooth this. In contrast, this and then effects, Gaussian blur looks more like true optical blur as from a camera or human eye rather than a blocky or artificial blur. So this is basically this is basically what we wanted it to do. Yeah. So what if I want to print out the text the way it was? So let's look at that. So originally we had our text. So where do we have our text here? We have our text here. And then what do we do with that? So let's just say we have our T. Just create a dummy here. And then create a dummy here. Then of course for each text we just append it to here. So I've gotten my text here, so I'll just say T is equal to I'll just say T plus just a space. I think I'm not being too consistent with this. Let me just be a bit consistent. Plus our text. Alright, so it will just be adding the text to this after the then once that has been done, I'll just at the end of the day it has finished everything. I'll simply print. Let's run this and see where it takes it to. Alright, so we saw this already. So you can see Gaussian blur uses this, and this is the text we wanted to see, which you can simply copy and do whatever you wish to do with it. So if you want also build a streamlit, this has already been done. I'm going to give you a link to a streamlit streamlit app that does this, which is basically a plug and play system. I will send you the link to the Streamlit app. Of course, you can also build a Streamlit app that does the same thing. You can also build a Gradio app that does the same thing. So that will be a video for another time. Or you can simply check the link. You will see the link to the Streamlit code there, and then you can just copy it, and it's very easy. All right. So thank you very much. That's basically the end of this. Please, if you have any question, add it in the comment, and don't also forget to like or share this video. It means a lot to me, and it also means a lot to the channel. It gives me motivation to keep going. So thank you very much.